the arrangement of electrons into subshells. So you know already that electrons orbit the nucleus. You know already that they orbit the nucleus in these energy levels which are called shells, and that the bigger the number of the shell, the further out they are from the nucleus. What we haven't told you up until now is that these shells are in some cases, most cases, split into subshells. So this second shell, for instance, is split into 2 subshells, and we give them a letter, so shell 2, subshell S, or shell 2, subshell P. The third one is split into 3 subshells, S, P and D. The fourth one is split into S, P, D and F. Within each subshell, the electrons can orbit the nucleus in a range of directions, and those directions are called orbitals. Each orbital can hold up to 2 electrons. So what we do is we put 1 electron into each orbital in that subshell, and then we add a second one into the next orbital. So any S subshell has only got 1 orbital. That's the green dot up there. Okay, so you pop 2 into there. Then we move on to the P subshell. We've got to fill S, and then we go on to P. That's got 3 different dimensions, 3 different ways in which we can orbit the nucleus. So we pop 1 electron into the first, 1 into the second, 1 into the third, then we go back and put 1 into the first again, another 1 into the second, and another 1 into the third. Okay. Because the P subshell has got 3 orbitals, it can therefore hold 6 electrons. The S subshell has got 1 orbital, it can hold 2 electrons. The D subshell has got 5 orbitals, so it can hold 10 electrons. Okay, so these are all the subshells that we've got. So in shell number 1, there's 1 subshell. It's got 1 orbital in it, so it's got a maximum of 2 electrons. The second shell is broken up into 2 subshells, the third into 3, the fourth into 4, the fifth is also into 4. Okay. Any subshell which has the letter S holds 2 electrons in 1 orbital. Any with the letter P holds 3 orbitals, so 6 electrons. D has got 5 orbitals, 10 electrons, and F 7 orbitals, 14 electrons. Okay. When we're filling them, just like when we talked about filling shells, what we're doing is we're filling them with the closest ones to the nucleus first. What we're actually saying is the ones which have got the lowest energy get filled first. Okay, because the closest ones have actually got the lowest energy. So we start by following this yellow line. So you see it says there 1s2. That means shell 1, subshell S, and the little 2, that is how many electrons we can fit in it to the absolute maximum. Once that's filled, we go into 2s, we put 2 in there. Okay, so for instance, carbon has got 6 electrons, so whereas previously you might have just said 2 in the first shell, 4 in the second, that's still true, but the 2 in the first shell we know are in shell 1, subshell S, and there are 2 of them, so we write 1s2. The 4 that are in the second shell, the first 2 go into that 2s subshell, so we write 2s2, and then 2p2. There's 2 of them go into that next p subshell. And we just keep on putting them in until we don't have enough. Okay, so that p subshell could hold up to 6 electrons, but I don't have that many. I only had 2 left to put in it, so it becomes 2p2. Something like aluminium, 13 electrons, so we dole them out until we get to 3p. We've only got